This picture is called an Argand diagram. And if you remember, previously we had a different name for this. We called it the complex plane. Okay. Plane, complex plane. Where you remember the x-axis being is the real axis now. So all real numbers live on this line. And imaginary numbers live where you used to see the y or the f of x axis. Okay. So remember, horizontal real, vertical imaginary. Now, this is what I want to teach you new today about this. Go ahead and put 4 little dash marks here, 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 and here. Okay. I want you to put a 1 right here, an I right here, a -1 right here, and a -I right here. Okay, now let's observe something that has thus far been unexplained. I equals I. I squared equals -1. I cubed equals -I. I to the 4th power equals 1. I to the 5th power equals I. I to the 6th power equals -1. I to the 7th power equals -I. I to the 8th power equals 1. In most classes, Algebra 2 type classes, math models, pre-calculus, you are merely given this information and you're told to memorize. So you're trying your best to remember. Now, wait a minute, I to the 3rd power, that's what you try to memorize it. But this is a terrible way to teach you what is happening here, okay? Because the better question would be to ask, Mr. Morelli, how do you know? How are you coming up with it so fast? Did you memorize it? Is that what you're doing? Okay? The answer is no. I am not memorizing. So I hate memorization. Hate it. I hate it. There are some things you need to memorize. It's okay if you didn't write that down, okay? Because I hate that. Some things you got to memorize, like the quadratic equation. That's helpful to memorize. There's other rules. Exponent rules are good to memorize. Product rule, quotient rule, all that good stuff. But as far as this goes, it's better if you don't memorize it. It's better if you just learn what is happening in the background. So I want you to watch this, all right? 1 times I is I. Does that make sense? Just like 1 times x is 1x, we just call it x. So I want you to draw this with your pen or pencil. I want you to draw, this is a counterclockwise rotation of 90 degrees. So you've drawn a counterclockwise rotation of 90 degrees. So you started at 1, and you multiplied by I, and that ended up rotating counterclockwise, which I'll call CC, by 90 degrees. And now you're at I. So I'm going to say this out loud. I is merely a 90-degree counterclockwise rotation out of the real axis purely onto the imaginary axis. Now, let's take that I. Okay, let's multiply by I again. I times I is I squared, just like 2 times 2 is 2 squared. Pi times pi is pi squared. Caitlin times Caitlin is Caitlin squared. Okay? I times I is I squared. But remember, multiplying by I is merely causing you to rotate counterclockwise by 90 degrees. I'm going to say it again. Multiplying by I is merely causing you to counterclockwise rotate by 90 degrees. So let's go from here, and let's counterclockwise rotate by 90 degrees. What number am I pointing at now?
-1.
-1. This is I squared. Now, let's take I squared. So this is -1. Let's take I squared and let's multiply by I again. Remember, multiplying by I is merely rotating counterclockwise by 90 degrees. So let's start here at -1, aka I squared, and rotate by 90 degrees. Now what am I pointing at? -I. So remember your product rule for exponents. This is I to the second times I to the first, which equals I to the 2 plus 1, which equals I to the third power, or I cubed. But look down here, I'm pointing at -I, so I to the cube must equal -I. Now let me rotate one final rotation, which would be taking I cubed and multiplying by I again. Remember, product rule of exponents, I to the third times I to the first is I to the 3 plus 1, which gives me I to the fourth. And if I rotate 90 degrees, look where I'm pointing. What am I pointing at?
1.
1. So I to the fourth must equal 1. So here's where I can keep going forever. I to the fifth is just another counterclockwise rotation. So I to the fifth is I. I to the sixth is the same as I squared, which is -1. I to the seventh is -I. I to the eighth, I'm back at 1. I to the ninth, I'm at I. I to the 10th, I'm at -1. I to the 11th, I'm at -I. I to the 12th, I'm back here. I could go on forever. All you're doing is rotating 4 quadrants, okay, 360 degrees. Notice that there are 4 rotations happening. So think about it this way. Every 4th rotation, you're back at 1. So let me show you the trick that is never taught, okay? Somebody give me a number between 25 and 100. 30. Perfect. So let's find out what I to the 30th power is. Now, we could start here and go I to the first, I to the second, I to the third, I to the fourth, I to the fifth. You could do that, and that would get you the correct answer, right? But it takes a long time. Just remember what I said. Every 4th turn, you're back to 1. So if we take 30 and divide by 4, we're going to find out how many total rotations there are. So how many times does 4 go into 30? What's the closest? 4 times 8 is 32. So back off. 7. So we put a 7 here. 7 times 4 is 28. What's the remainder? 2. So we have 30 equals 7 with a remainder of 2. So here's the trick. That's 7 full rotations, back to 1, and then I just need to do 2 rotations. So 1, 2. So I to the 30th is -1. You see how cool that is? Let's do another one, okay? Give me another kind of big number, but keep it under 100. Give me something without a 0, something kind of weird.
45.
45? 45. Okay, so I to the 45th power, we're going to find out what it is. So we're going to take 45, and we'll divide by 4. 4 goes into 4 one time. That gives me 4. How many times does 4 go into 5? 1 time. 1 times 4 is 4. So I've got a remainder of 1. So it's 11 remainder 1. That's 11 full rotations, and then 1 more. So what is I to the 45th? A positive I. Okay? Let's do one more. I want to make sure you get this. Give me a big number, something bigger than 100, something that would be totally insane.
85.
Bigger than 100.
85.
200 what? Make it hard. 290. Give me the last digit.
666.
291. 600. I'm not doing that one. So I to the 291. Can you imagine having to go 1, 2, 3, 4? Okay. So I to the 291st power, we just take 291 divided by 4. Let's see, 4 goes into 29 7 times. That gives me 28. Here's 1, 11. 4 goes into 11 2 times. 2 times 4 is 8. So there's 3. So it's 72 remainder 3. 72 full rotations. Then I just have to do this. 1, 2, 3. So I to the 291st power is negative I. Is this easy? This is such a trick, right? And the amazing thing is it works. So here's where we bring it all together. Let's take I to the 753rd power times I to the 976th power. Can you even imagine how difficult this would be to do by using your hand to rotate around the circle 753 times? Okay. So first, let's figure this one out. Let's take 753 and divide by 4. 4 goes into 7 once. 4 goes into 35. How many times? 8. 4 goes into 33. 8. Remainder 1. Okay? So 188 total rotations and then one final rotation. I. So really, I to the 753rd power is just I. Now let's do this one for I to the 976th power. Take 976, divide by 4. 4 goes into 9 twice. Okay, that gives us 8. 4 goes into 17 4 times. That gives us 16. And then 4 goes into 16, exactly 4 times. So 244 perfect total rotations puts me back here at 1. So I to the 976th power is 1. So actually, multiplying I to the 753rd power by I to the 976th power is equivalent to multiplying I times 1. What is I times 1? I. So the answer, the product of that one is just I. Guys, is that crazy or what? Crazy. Do you feel like you've learned something new today? That is very good. See, that's what makes me happy. I'm proud of you guys. Thank you so much for your attention today. And please make sure to like, subscribe, and comment.